This video, we are going to see about shortest job first algorithm. It is a non-preemptive algorithm. Here we are having 5 different processes with its arrival time and burst time. Now we shall draw the Gantt chart. Gantt chart starts at 0th millisecond, but here we are having the first process P1 at first millisecond. So from 0 to 1, we don't have any process to execute. So we are marking like this. Then at first millisecond, we are having only one process. Because the second process, that is P2, arrives at second millisecond only. So at first millisecond, we are having only one process. So P1 only has to execute. The shortest job first algorithm follows the principle that which process has minimum execution time will be running first. That is, the minimum burst time will be running first. Here at first millisecond, we don't have any other process to compare. So no other way, we have to run this P1 only. This P1 will be run up to its burst time, that is 1 plus 7, 8 millisecond. Because this is a non-preemptive algorithm. In non-preemptive algorithm, while a process is running, no other process can disturb in between or can run in between the execution of another process. Okay. So this process will be running from 1 millisecond to 8 millisecond. See, at 8 millisecond, if you see, means we are having all the process because the last process P5 arrives at 5th millisecond. So now we can compare the burst time 5, 1 to 8. So which has minimum execution time? 1. That is process P3. This process P3 will be executing for 1 millisecond. That is from 8 to 9. Next, the process P4. Because the next minimum execution time is for P4. So P4 will be executing from 9 to 11 millisecond. Okay. Next, this P2, which has 5 millisecond execution time, will be executing next P2. That is up to 16th millisecond. Next, at last, the process P5, which has 8 millisecond execution time, that is a burst time, will be executing at last. That is 16 plus 8, 24. Up to 24th millisecond, it will be executing. So now we can calculate the completion time, turnaround time, waiting time and response time for each and every process. Okay. So completion time. See here from the Gantt chart we can calculate it. This process P1 gets completed at 8th millisecond. So the completion time is 8 millisecond for process P1. Next, for process P2, the completion time is 16th millisecond. For process P3, the completion time is 9th millisecond. Next, for process P4, the completion time is 11th millisecond. Last, for process P5, the completion time is 24th millisecond. Okay, then using the formula, turnaround time is equal to completion time minus arrival time, we can compute the value for turnaround time. It's simply subtracting completion time from the arrival time. It's 8 minus 1, 7. Likewise, I am subtracting the value and writing for each and every process. Then for waiting time also, we can compute using a value. Using a formula, that is waiting time is equal to turnaround time minus burst time. So, simply subtracting the turnaround time and burst time for each and every process, I am writing the values. Okay. So, for a non-preemptive algorithm, the waiting time and response time are same. So, here also we can write the same values.